Namaste everybody. My name is Harshvardhan and welcome to our channel Chemistry with Harshvardhan. Today we are back with another interesting topic of some basic concepts of chemistry, that is atomic mass unit and average atomic mass. Okay, so before moving ahead, let me inform you that we have started a Telegram channel where you can access the notes and quizzes. So you can join our Telegram channel whose link is available in the pinned comment and also the details of our YouTube channel. Okay, so let us start with our today's topic, that is atomic mass unit. Okay, so what is atomic mass unit? It is equal to 1/12 the mass of the mass of an atom of carbon 12 isotope. Okay, and it is equal to 1.66 into 10 to the power of minus 24 grams. Okay, so let us write it down. Atomic mass unit. Okay, as we said, it is equal to 1/12 the mass of an atom of carbon 12. Okay, so that means what? If this is an atom of carbon 12 isotope and you divide it into 12 parts, then every part of the carbon 12 isotope atom will be equal to 1 AMU, and that is equal to how much? 1 AMU is equal to 1.66 into 10 to the power of minus 24 grams. Okay, recently atomic mass unit has been replaced by unified mass, which is denoted by U. Okay, it has been replaced by unified mass U. Okay, so I hope I am clear to you up to this. Okay, now moving ahead, since what did we say? That this atomic mass unit is basically used to measure the mass of an atom. And why was it required? It was required that the mass of atom is very less when it comes to the conventional units for weight measurement which are there. Okay, so as we see that 1 AMU is equal to how much? 10 power of minus 24 grams, and the mass of the atoms irrespective of the elements are in this range only. Okay, so this new unit has been introduced. Okay, now moving ahead, if we look at AMU, it is basically used to measure the mass of an atom. So what are the ways in which we can measure the mass of an atom? It is basically that what you can do is you can mass the individual weight of the subatomic particles and add them together. So if you consider this to be an atom, okay, and here you have its nucleus. So an atom basically has three subatomic particles, that is protons and neutrons, which are present in the nucleus, and then electrons which are present outside the nucleus. And if you add mass of these three subatomic particles, what you can obtain the mass of this atom. So we are going to do the same. Okay, so mass of an atom is equal to what? It is equal to mass of electrons plus mass of protons plus mass of neutrons. Okay, now we know that the mass of proton and the mass of electron is equal to what? It is equal to the atomic number of that particular element. Now if you look at this number of neutrons, so how will you calculate the number of neutrons? We know that mass number A is equal to number of protons plus number of neutrons, correct? So if we subtract the number of protons from mass number, we can get the number of neutrons, and we know that number of protons is equal to how much? It is equal to the atomic number. So this is basically what? A minus Z is equal to N. That means what? Number of neutrons is equal to what? Atomic number subtracted from what? Mass number. Okay, so this becomes what? Mass of electron is equal to what? It will be how much? Your number of electrons is equal to Z into 9.1 into 10 to the power of minus 28 grams, correct? And mass of proton will be equal to how much? Z into 1.66 into 10 to the power of minus 24 gram. This is the mass of proton, okay, and this is the number of protons present in any atom. And what will be the number of neutrons? It will be equal to what? A minus Z into 1.66 into 10 to the power of minus 24 gram. Okay, so the mass of proton and mass of neutron is almost equal, but if you take the exact values, you will find that mass of neutrons is more than that of mass of protons. Okay, now moving ahead, what you can see that the mass of electrons is very less in comparison to mass of protons and neutrons. That is why it is ignored when we calculate the mass of an atom. Okay, so we ignore this value, and now what is left over here? Z into 1.66 into 10 power of minus 24 grams plus, now if you open this bracket, what did you get? A into 1.66 into 10 to the power of minus 24 grams minus Z into 1.66 into 10 to the power of minus 24 grams. Okay, now since these two values are same, we can cancel it, and what do we get? A into 1.66 into 10 to the power of minus 24 grams. Okay, A is what? It is our mass number, and this is basically, if you look at this value and this value are same, so it is what? It is AMU. That means what? If you find to mass, or if you need to find the mass of an atom, if you know the mass number of that particular element, and you can simply do what? You can add AMU to that particular mass number of that particular atom, which is of a particular element. Okay, so anyway, what does it mean? It means that the mass of an atom, okay, if you know the mass number of an element, you can simply write the mass number AMU. I hope I am clear to all of you, correct? So now you can note it down if you want, and then we'll move to another topic. Okay, now the next topic is what? The next topic is our average atomic mass. Okay, so what happens is basically many of the elements in our periodic table, they occur in form of isotopes. That means you cannot assign a particular mass to those particular elements. So we find a representative mass for those elements using average atomic mass. Okay, so how do we do it? What we basically do is we take the percentage abundance of that isotope divided by 100 multiplied by mass number of that particular, or mass of that particular atom of that particular isotope, and we do this for all the isotopes, and then finally add all of them to get what? To get the average atomic mass. Okay, so we'll look at it with through an example. Okay, so let us put the heading average atomic mass. Okay, so average atomic mass is equal to, suppose that if there are two isotopes, then percentage abundance of isotope 1 divided by 100, okay, into mass of isotope 1, correct, plus percentage abundance of isotope 2 divided by 100 into mass of isotope 2. Correct? Let us understand this with the help of an example. Suppose that we have an element X and it has two isotopes. Okay, one has got mass 20 AMU and another has got mass 40 AMU. Okay, and its percentage abundance is 20% and its percentage abundance is 80%. Okay, now if we try to find out its average atomic mass, okay, then average atomic mass will be equal to how much? Okay, then simply use this formula. Okay, so 20% of 20, so 20 by 100 into 20 plus 80 by 100 into 40. Okay, simply we had put the values in that particular formula. Here the percentage abundance of isotope 1 is how much? 20%. Okay, and its mass is how much? 20 AMU. Similarly, for another isotope, its percentage abundance is how much? 80% and mass is how much? 40 AMU. So what do we basically get? We will simply solve it. This is 4 plus 8 4 ja 32. So this becomes how much? 36 AMU. So this is what? Average atomic mass for this particular element X. Okay, I hope I am clear to all of you. Okay, now we are moving ahead to solve some PYQs. Okay, so if you have written, we will erase it. Okay, now next we are going to solve some PYQs and that will give us more clarity of the concept. Okay, now let us do the question. Right, this question was asked in NEET. So an element X has the following isotopic composition. X 200 is 90%, X 199 is 8%, and X 202 is 2.0%. Okay, the weighted average atomic mass of naturally occurring element X is closest to, your options are 199 AMU, second option is 200 AMU, third option is 201 AMU, and fourth option is 202 AMU. Okay, I will want that all of you should try to solve this question yourself first and then we'll solve it together. Okay, so solve it and write your answer in the comment section of this video. Okay, let us solve it together. So they have basically given the different isotopes, their percentage abundance and their mass, and we have to find the average atomic mass. Okay, so average atomic mass will be equal to what? Average atomic mass. So we will simply apply the formula that we have studied earlier. Okay, so only thing is that there are three isotopes, so we will have to do for all these three isotopes separately and then we have to add them. So this is how much? 90%, 90 by 100 into 200 plus its contribution is 8 by 100 into 199 plus 2 by 100 into 202. Okay, let us solve it. So this becomes how much? 180. Okay, and this becomes how much? 9 8 is 72, 9 8 is 72, 7 79, and this becomes 1592 by 100 plus 400 4 by 100. Correct? So this becomes how much? 180 plus 15.92 plus 4.04. Now add all of them. So we get how much? 180 plus 15.92 plus 4.04. Okay, this becomes how much? 6999. So this becomes how much? 199.96 AMU. Okay, and this is closest to which value? This is closest to our 200 AMU. This is more than 199 and this becomes 0.96. So this is close to how much? 200 AMU. So our 200 AMU will be the answer. Okay, so if you got it wrong or you were not able to do it, you can note it down. Okay, now we are moving to another question. Okay, it was asked in JEE Mains. So the another question is, write down the average molar mass of chlorine is 35.5 gram per mole. The ratio of chlorine 35 to chlorine 37 in naturally occurring chlorine is close to this was asked in JEE Mains 2020. Okay, your options are 1:1, 2:1, 3:1 and 4:1. Okay, try to solve it yourself and then we'll solve it together. Okay, solve it yourself and write the answer in the comment box. Okay, now let us try to solve it together. What is it saying? That they have already given you the average molar mass. Here they are talking about molar mass. Okay, so in molar mass nothing, you have to replace the AMU with grams. Okay, in next class we are going to discuss about the mole concept and there it will become more clear. Okay, so for now the process remains same, only the AMU will be replaced by gram, nothing else. Okay, so and they are asking you to find the ratio. So first of all, what we have to do, we will consider that the percentage abundance of chlorine 35 is X percentage and chlorine 37 will be how much? Since there are two isotopes, it will be how much? 100 minus X, because total abundance has to be how much? Total, if you add the abundance of both of the isotopes, it has to be equal to 100. So if one is X percent, another will be how much? 100 minus X percent, right? So let the percentage abundance of chlorine 35 be X percent, right? Then percentage abundance of chlorine 37 will be 100 minus X percent. Correct? So now we have to do the same process that we have just learned. So it becomes how much? X by 100 multiplied by 35, because our X percentage is isotope of what? Is which isotope? Chlorine 35, plus 100 minus X by 100 into 37 is equal to how much? 35.5. correct? Let us solve it. So this becomes what? 35x by 100 plus 3700 minus 37x by 100 is equal to how much? 35.5. Now transfer this 100 to the right hand side. So this becomes how much? 35x plus 3700 minus 37x is equal to 3550. So this becomes how much? 3700. If you bring this 3550 on the left hand side, this becomes how much? Minus 3550 is equal to 35 minus 37 is equal to minus 2x. If you send it to the right side, it becomes what? 2x. So 150 is equal to how much? 2x. So x will be how much? X will be equal to 75. So that means what? The percentage abundance of chlorine 35 will be how much? 75%. And that of chlorine 37 will be how much? 100 minus 75, that is 25. So if you take the ratio, it becomes what? 75 by 25, that is 3 by 1, and the answer becomes what? 3:1, 3:1. So this option 3:1 becomes our answer. Okay, so if you have not been able to do, you can just note it down. Okay, so this will be all for today. We will meet again in next class with new topic. Thank you very much.